Hello guys, my name is Aditya and we're back again with another video. In the previous video we have covered these 5 points and today we'll be covering histogram and the density plots. So if you have not watched the previous videos, you can always go and watch. The uh, link for the playlist is given in the description below. So I'll be running these two cells, okay, these two cells. I'll need this species column, so I am not dropping this species column. And this is just a glimpse of what we have done earlier. Okay, so we have covered scatter plot, LM plot as well, swarm plot, box plot, violin plot. Okay, and today we'll be covering histograms and density plots. So what is actually a histogram? A histogram is a graph that shows the distribution of a column values in a data set. We'll see what does it mean. Okay, so first, we need to write for histogram. The command is dist plot. This means distribution plot. Okay, histogram shows the distribution of a column values in a data set. So we use the distribution plots to plot the histogram. So the command is dist plot, and A is the series where we give the column name. Okay, so we don't have X, Y here. We have A. Okay, so we give the column name to A. So data set dot sepal length. So our data used to look something like this. Okay, it has sepal length, sepal width, petal width, and species. These are all continuous values, and this is categorical. Okay, so let us just plot this and let's see what's the output. So the output is something like this. Okay, so between 4 to 5, 6, 7, 8, and up to 9. Okay, so this curved line is the density plot, and this bar plot kind of thing is the histogram. That this shows that between 4 to 5 we have nearly 15% of the data. Between 5 to 6, let's say between 4.5 to 5, we have 15% of the data. So between 5 to nearly, let's say 5.5, we have some around 40% data, and so on. Okay, so this is the distribution. Okay, so this is suppose like in dataset.sepal, and there is a value 5.1, and we have some values like, let's say 4, 3, 2, 5, 6, 5, 4. Okay, so it will show that there is only 1 2 occurring here, right? There is only 1 2 occurring here. There is only 1 3, there are 2 5s, there are 2 4s, and there is only 1 6. So this shows how the data is distributed. Okay, and this smoothened curve, assuming that the data is normally distributed. Okay, this curve is calculated by getting the mean of this data and the standard deviation of this data, and assuming that the data is normally distributed, this normal curve is obtained. This is called kernel density estimate, KDE, also known as the density plots. Okay, so if you don't want to see the density plots, what you can do is KDE is assigned to false. False is assigned to KDE. So we don't have that KDE anymore, right? Now see, so also this changed from 4.5 to 5. So now the bin size is 0.5. Okay, we can also play with the bin sizes. Let me just show you once. Bins will be, let's say my bins will be 4 5. Let me start from 3. Okay, so we'll have the first marker here at 3, then 4, then 5, and so on, 6 7 8 and 9. If you want these many bins to be there, here the bins are 4.5, 5.0, 5.5. These are called bins. Okay, so if we want these bins to be there, then we can directly write bin is assigned to my, sorry, bins is assigned to my bins. This is the command, right? So now we have the bins in this way, right? we have a proper bin of 4, 5, 6, 7, and 8. So it groups data based on the given bins. Okay, these are called the bins. So you can write it that way. If you want KDE also, then you can just remove this and do the KDE, right? Now, what if you don't want to use this distribution plot and you want to directly get the KDE, that is called the one dimensional KDE plot. Okay, so what we can write is sns.kde plot. KDE means kernel density estimates, also known as the density plots. Okay, so we'll write here data is data set, and in the x-axis we have sepal length. Okay, so this will work for us. Let us just run this cell. Okay, it is not working, showing some error, could not convert. Oh, we just need to write it this way, in a similar way as we have written above. Okay, there is no problem with that if we write directly like this, and we have to give it to data. Yes, so see, this is the KDE plot of this above diagram. Okay, of this histogram. This is the smoothened curve. Okay, so I have already discussed how this smoothened curve is drawn by calculating the mean and the standard deviation, assuming that the data is following a normal distribution. Okay, so this is how we get the one-dimensional KDE plot. Now what if we want to get a two-dimensional KDE plot? Okay, let me just write here two-dimensional KDE plot. Down and run. So in order to get a two-dimensional KDE plot, we need to write the command is joint plot. Okay, sns dot joint plot, and here we give x-axis is this thing, dataset dot sepal length, and we'll be giving y-axis as dataset dot petal length. So if we do this, then what we get is, okay, this gives us the scatter plot based on this histogram. Okay, but see, okay, let me just make it this way first. Okay, if we don't want to get the scatter plot, what we can write is kind is KDE. So this is what we got. Okay, so you can see that, let me just zoom out a little bit. So you can see that this curve is actually the smoothened curve of this histogram, and this curve is actually the smoothened curve of this histogram. Okay, so what we can infer from this data is, see, uh, for sepal length, the KDE is the one-dimensional KDE looks something like this. Okay, and for petal length, the one-dimensional KDE looks something like this. The one-dimensional KDE ranges from 0 to 0.8, and for the sepal length, the one-dimensional KDE ranges from 4 to 8. Okay, just before 4 and just after 8. So what does this two-dimensional KDE actually shows us? Okay, it shows that in which area the data is more dense. The darker areas, the data, there are more data in that place, and in the lighter towards the outer boundary, the lighter areas, there are less data. Okay, we can see it in this way, such that, see, between sepal length 6 and 7, okay, and between petal length 4 and 6, we have too many data, right? Even in the scatter plot, if we see between 6 and 7, between 6 and 7, and between 4 and 5, we have too many data at a single place, right? So this shows the density. At this position, the data is more dense. It can be seen here. At this position, the data is more dense. There are more data at this place, and also at this place. Okay, there are more data, but towards this outer boundary, the data is less. So this is how we can visualize a two-dimensional KDE plot. Okay, just we need to write is KDE here, And there are many more attributes along with this. You can always try it out by going into the documentation. If you want, if you have some specific questions, kindly put it down in the comment section. I would love to answer those. And thank you very much for watching. This was all for today. Have a great day ahead. And if you actually like the video, hit the like and the subscribe button. Also share it with your friends. So have a great day. Bye bye.